Security considerations in PCF. Security groups and container-to-container security, or C2C security. In this video, we will demonstrate managing application security in PCF. We'll discuss container-to-container security in PCF. And we'll be discussing security groups in PCF. So let's look at this example application architecture, and we'll analyze it for some security pain points. And a lot of these pain points are PCF specific. So let's go from left to right. Where a request originates from a mobile device and it's going to hit our F5 load balancer, which will then route that request to an endpoint and an API gateway. And then finally, the API gateway will have to a route in PCF where the Go router takes over. It's not pictured, but the Go router is in here. And it's going to route that request to an available app instance. So eventually it gets resolved down to host port of an app instance. And again, so we have app A and we have app B, and app A makes a call to app B, and both of these applications are running in PCF. And so what this can mean is if app A wants to make a request to app B, it's going to reference an F5 VIP or an API gateway endpoint or a CF router endpoint, and it will then have to go basically, this from app A to app B can have to go out and then back in. So that's one of the pitfalls there, but with the container-to-container networking, it solves that problem. So we can use the discovery server and we can use the Spring Boot discovery client library to facilitate container networking. And one of the features there is container-to-container authentication, and that's a new feature as of November 2017 to PCF. And so we have a couple of authentication points. We can authenticate at the gateway. We could authenticate at the CF Go router using a root service, and we can authenticate at the application. And we can also have container-to-container authentication. And keep in mind that the F5 load balancer and the API gateway, these can actually be switch places. So we can have an API gateway sitting in front of the F5 load balancer. We can have an F5 sitting in front of the API gateway. There's a couple different situations here. However, those are the primary places to authenticate. Now, it's worth noting, though, if we want end-to-end security, that as of right now, one of the most common solutions is to have Spring security in your Spring Boot applications, with your Spring Boot applications secured with OAuth 2 and JWTs with Spring Security. So that's probably the default solution. And the reason for that is because there's no two-way SSL between the gateway and the app. So you're going to have to authenticate requests in the app. Usually, you're going to have either a bearer token or some other type of authentication token that you're passing in the header. So again, two-way SSL is not an option with PCF. Because two-way SSL cannot be achieved between an API gateway and apps in PCF, authentication at the app is needed. Securing Spring MVC controller methods with Spring Security is common. Okay, remember that. So application security at the API gateway. So it's a good practice to expose our APIs via an API gateway, like the AWS API gateway, like Azul or Apogee, to name a few. Those are some API gateway products. There's fully managed API gateways, and there's self-install on-premises API gateways. Azul is an open source, free API gateway or edge service that you can install yourself, or you can buy a proprietary product like Apogee that you can install on-prem, or you can use the fully managed service. And so most API gateway technologies are cool because they allow you to configure a security filter or authentication mechanism to protect endpoints. So you can have two endpoints. You can have like a get user and a get person endpoint, and one of those endpoints can be secured with, can require SAML assertions, the other could require OAuth 2. And so you're flexible with the way you can authenticate endpoints with the API gateway. It's a great tool. Again, in this case, the F5 could be sitting behind the API gateway instead, rather than the API gateway sitting behind F5. It's just something to remember also. So endpoint security with Spring Security and OAuth 2 with JWT. So what's a JWT and what's OAuth? What are some of these terms? So JWT stands for JSON Web Token, and it's nothing more than a JSON string. And in this JSON string, there's a few fields. One of them is claims, and a claim could be like, hi, my name is Braith, or it could be user ID or some specific field that you want to add to your authentication token. But typically, this JWT will have a principal, and it'll contain the credentials of the user, this token. And the token is encrypted. So your applications, if you're using RSA, should be able to decrypt the token. There should be a public key, an asymmetric key that you're using to decrypt the token and to extract the claims, extract the principal from the token. So that's JWTs, and OAuth is a little bit different. There's 4 flows of OAuth, and all really OAuth is it provides a specification for an auth server, and the auth server, what it does is, if we want to make a request to one of our web services, we got to go to the auth server. To get the token, we have to pass in some information, And we get the token. Now, once we have the bearer token, now we can make requests to the OAuth protected services. That's the whole thing in itself. It's sort of out of scope. I would definitely suggest looking up Spring Security OAuth 2 and going to the Internet Engineering Task Force has a request for comments, and they have the formal OAuth 2.0 specification. Read it and look at the 4 flows of OAuth. It's very clear and concise, but it's a little bit out of scope, but it's very important. So when we secure our apps with OAuth 2, our apps will require a signed bearer token, usually in JSON Web Token format. The token is basically an encrypted JSON string with information about the principal and other claims or fields that we choose. So what is app-to-app or container security? Well, remember how in the beginning of this video I said that if app A wants to talk to app B in PCF, it has to go out and come back in, meaning it has to make a request to either the F5 or an API gateway if that's sitting in front of it, or at least it'll have to talk to send the request to the CF router, to the Go router. But with container-to-container networking, we don't have to do that. So with container-to-container networking, we can have a discovery service. And the discovery service, so every time like let's say we have several instances of app B, like 3 or 4, and they keep spinning up and spinning down. Every time an instance of app B, because it's a discovery client, it'll register itself with the discovery server. But when an app A wants to make a request to app B, it'll fetch a healthy host and port for app B, for an app B instance. It'll send the request directly to the host and port. It doesn't go out and come back in. So that's the advantage of container-to-container security. And on top of that, the cool thing about container-to-container security is you can actually say, you can configure that within PCF that app B can only accept requests from app A, sort of like a whitelist. So in here, so for instance, what this would do is this would make it so you don't have to have Spring Security code in application B. You don't have to add any complex security code. Security code it's kind of complicated sometimes. Not a lot of people really fully understand Spring Security, and it becomes sort of a complex endeavor to really get Spring Security and security in all the apps. So anytime you can not have to put code for security in an app, that's typically a good thing. It's better to handle it in a codeless manner. You can get code out faster, and that's one of the things that's one of the themes of PCF is we want to get products to market faster. So less code helps that happen. So security groups. So what is this application security group, or ASG, in PCF? And this is very important. Hear me out here. So when you're in your organization and your PCF, there's always going to be issues where you push your application to PCF and your application is writing to a database that is not managed by PCF. It's in some other network. It's in a different part of your organization's network. And typically what happens is your applications don't have permission to talk to external resources. The application can't send requests to external resources because of the application security groups. It's outbound network rules for a set of resources in PCF. So this always happens in every organization I've been in. You always might have to talk to the PCF admin to have him modify the security groups, because if you see this X between app A and this database, so app A wants to talk to this database, but because the security groups are blocking the request, so it's for network egress rules. The application security groups are a set of network egress rules that make it so your applications cannot send requests outside of PCF. If you want it to talk to this database outside of PCF, you have to ask your PCF admin to modify these application security groups. That's what that is. And so ideally, you want app A to talk to the database, and you don't want to be blocked by the security groups. This can slow things down a little bit, so you want to make sure that your ASGs are configured properly so you don't get blocked. No blockers. To summarize, we can leverage container-to-container security for application security in PCF. In order to leverage container-to-container security, we need to leverage the discovery service. In the next video, we'll be discussing resource limitations in PCF.